So I'm going to be doing number 11 from chapter 12, and after reading the problem, we learned that a 15-meter ladder is resting against a frictionless wall, and the ladder weighs 500 newtons, and it is making a 60-degree angle with the horizontal. And in part A, there is an 800 Newton firefighter who is standing 4 meters from the bottom of the ladder. And for part A, they want us to solve for the horizontal and vertical forces that the ground exerts on the base of the ladder. And those forces are friction and then the normal force of the ground. So first, we are going to just draw all our forces acting on the ladder, which is the normal force of the wall, the weight of the ladder, the weight of the firefighter, and then our two forces down at the origin. And then we're going to make y positive up and then x positive to the right. So for part A, first we're just going to sum up the forces in the x direction, which is the normal force of the wall minus friction, and that equals 0, so we can just say the normal force of the wall equals friction. Then we want to sum up the forces in the y direction, which is going to be the normal force of the ground minus the force or the weight of the ladder and the weight of the firefighter. And then that is set equal to 0, so we know that the normal force of the ground is equal to 1,300 newtons. The next thing we want to do is sum up all of our torque. And we know that first we're gonna make the ladder like our new x-axis to find the signs of our angles, because torque is the distance times radius times or the distance times force times sine of the angle. So the normal force of the wall times 15 meters, because we're using the origin as the base of the ladder, times cosine 30 degrees, or it's sine 60 degrees, minus 500 newtons times half of the length of the ladder, and sine 30 degrees minus 800 newtons, 4 meters, because that's how far the firefighter is from the bottom, times sine 30 degrees is equal to 0. So moving that equation around, there you go. You can solve for NW, which is 268 newtons, and we know that the normal force of the wall is equal to the frictional force, so we know friction is 268 newtons. And that is part 1. Okay, so for part B, we want to find the coefficient of static friction when the ladder is barely slipping, but this time the firefighter is going to be 9 meters up the ladder instead of 4 meters. So we do the same thing as we did in part A, except instead of 4 meters, we make it 9 meters, and the torque is set up exactly the same because that's the only difference. And then so solving for the new normal force of the wall, we get 421 newtons, and that is also equal to the frictional force. And friction equals mu times the normal force of the ground. And the normal force of the ground is still the same, it's 1,300 newtons. And that's what we found in that first part of the sum of the forces in the y direction. And we can plug in our new frictional force and then the normal force of the ground to solve for mu, which is 0.324. And that was number 11 on chapter 12.